Hello, my name is Paul Holmes and I'm the Managing Director of Wirtgen Limited. Unfortunately I can't be with you today, but it's a real pleasure to be able to talk to you today about the current and future innovations in asphalt manufacturing and laying that the Wirtgen Group are introducing through its leading brands of Wirtgen, Vögele, Ham, Kleemann and Benninghoven. The Wirtgen Group has been pioneering sustainable road building for a long time. In 1975, Benninghoven used recycled content in asphalt production for the first time. Wirtgen introduced the cold milling machines to mill asphalt without prior heating in 1979. And in 1990, the option to run Kleemann crushers and screens by connecting them to an external electric grid became available. The first diesel-electric road paver offered by Vögele received the German Engel Eco Certificate in 1992. And to significantly reduce fuel consumption of ham rollers, Hamtronic was introduced in 2000. Overall, the Wirtgen Group provides a circular process solution to road construction and rehabilitation. Our mission, close to our customers. This message is clear and simple. We are answering the fundamental needs for smarter, safer and more sustainable road construction, so our customers and our clients can shape tomorrow's world. Reducing CO2 and joining up the production systems in road construction through digitalisation are driving innovations in our industry. The diagram shows the influence of our production systems on CO2 emissions in a typical road building project. As a starting point, we have 100% virgin mineral and fossil fuel heating the asphalt. As you can see, 30% of the total carbon is caused by the processing and transport of bitumen. And the largest percentage, 45%, by the drying and heating of the virgin material in asphalt manufacturing. Therefore, innovating in asphalt manufacturing is the first place to start. We have identified 6 areas where CO2 reductions can be achieved in the manufacturing of asphalt and the likely CO2 savings per tonne of asphalt if implemented. I will quickly focus on 2 areas of innovation. As I mentioned earlier, the impact of bitumen on the total CO2 emissions of road construction projects is large. It is therefore obvious to reuse the bitumen containing in the wrap material. By using 60% wrap material, the CO2 emissions can be reduced by up to 17%. The next generation of wrap priority plants, or RPP plants, are now available. They offer the highest levels of recycled wrap material in new asphalt available on the market. Here is an example of an RPP hot gas generator plant that we built in Germany and has been established for 3 years. As we've talked about, the ability to use recycled wrap material from asphalt planings or breakout material or return loads back into new mixes greatly improves the CO2 reduction in new asphalt mixes. The new Benninghoven RPP plant optimizes this use of wrap material. Brand new hot gas generator technology allows wrap material to be heated closer to the target temperature for the final asphalt product, and I'll explain this later in the video. The new wrap priority plants combine the ability to use RAP as the primary source of aggregates, which is added through the cold feed hoppers. And the philosophy is that RAP will always be the primary aggregate source, rather than in an addition to virgin material in more traditional plants. And the whole plant design has been enabled to allow the flow of RAP material through the asphalt plant. In conjunction with hot gas technology, RAP can be heated up to the target temperature for the asphalt, anywhere up to 160 to 180 degrees, without the need to superheat virgin materials. This allows close to 100% of recycled asphalt to be used in new mixes. As can be seen here, the plant is designed to handle RAP material in the most optimal way. The indirect heating of the RAP material ensures that any volatile organic compounds that are given off by the RAP material are contained within the drying process, and therefore emission levels of VOCs are contained within the parameters of the plant. Once the RAP material has been heated to the target temperature of 160 degrees, it is stored in large silos on top of the mixer, weigh hopper and mixer, and discharged in exactly the same way a traditional virgin aggregate would be into the mixer in the required dosages and percentages of the new asphalt mix. As I mentioned, by heating the RAP material up to the target temperature of the asphalt enables or ensures that virgin material does not need to be superheated. The crucial advantages of this RPP hot gas generator plant from Benninghoven is the ability to meet even larger quantities of RAP in new asphalt. But quickly, back to the concept of production systems. The ability to use higher percentages of RAP in new asphalt is determined firstly by the specification and national and local authorities' need to do more to increase these levels in new mixes. The production system for RAP starts with controlling the milling process and its parameters. The ability to remove different layers or qualities of aggregate to selectively process fresh RAP and blend different gradings, qualities via digital systems such as Benninghoven's second generation recipe generator brings together all aspects of this production system. The largest CO2 reduction lever is alternative energy sources for asphalt plant burners. We already use a multitude of oils, gases and biofuels, and the volatile nature of current energy pricing requires quick decisions and the ability to switch fuel sources. Future fuels such as DME and green hydrogen provide the future for zero CO2 emissions when they are commercially available. Burner technology was where our Benninghoven business was founded and remains a core competency. We have developed a new burner generation to address the challenges of fuel combinations alongside understanding the production systems required for future fuels such as hydrogen. Our first innovation is our tri-fuel burners, which with our new CMS burner control systems allow our burners to burn combinations of up to 3 different fuels at once. In addition, unlike existing burners, to switch fuel mid-production requires a burner shutdown and restart. The CMS system allows immediate switching without any downtime. Hydrogen is very much seen as the future fuel for asphalt manufacturing, although from the experience we have gained during our intense R&D process, it is not as straightforward as many would have you believe. In a typical 20 megawatt burner using natural gas, it uses 1,754 cubic meters per hour of gas. If you want to do this with hydrogen, hydrogen is much lower energy density than you need 6,750 cubic meters for a 20 megawatt burner. However, most people talk about blending hydrogen with natural gas. The question is this blend by volume or by energy? The different ratios give very different gas volumes and very different CO2 savings. The fact is, in the example with energetic representation, no natural gas burner is able to implement mixing ratios at a capacity for any meaningful CO2 savings, and the burner will burn. We started our R&D process, bench modelling the hydrogen flame, understanding the highest speeds of combustion and changes to the head cowlings required. Also, the greatly increased volumes of gas required affect not only the burner design, but the drying drum and bag filter for optimum performance. Again, this is our understanding of the drying process as a production system and not just a series of individual plant components. For real CO2 savings, the goal must be able to use 100% hydrogen, but not to have to. One must be able to use all the fuel variants taking into account fuel availability, fuel prices and CO2 emissions of those fuels. From our R&D facility working in partnership with a customer in Norway, we have installed as a retrofit a hydrogen burner on an existing plant. This has been running since October 2023 and has produced several thousand tonnes of asphalt. Recently, we have installed our second hydrogen burner for the same customer in Norway. But the hydrogen burner is only part of the solution. We have developed the technology, the availability of green hydrogen is the next piece of the puzzle, and how to transport it and feed an asphalt plant. For hydrogen to be transported in any meaningful quantity, circa 0.8 of a tonne per trailer, requires it to be transported at pressures of 350 bar. Again, our production system approach has developed the technology to safely drop down this pressure from 350 bar to the required 0.3 of the bar at the burner. We are continuing our pilot project with trusted partners and move to series production at the beginning of 2025. Turning to asphalt laying and rehabilitation. In the actual laying and rehabilitation of asphalt, we want to move away from the individual machines to considering the overall process. This holistic approach puts the focus on the process that is best suited to realise a construction site efficiently, profitably and sustainably. That's why we're also recommending calculating emissions based on CO2 per work done, i.e. cubic metres of milled or paved square metres, rather than individual machine levels. Innovations are moving in two main areas. Firstly, A2A, automation to autonomy, as machine transitions from being fully manually operated to fully autonomous systems that do not necessarily rely on operators' input. We are currently somewhere between levels 2 and 3. And secondly, digitalisation. With increasing digitalisation, we are also talking about precision road construction. This allows decisions to be made faster and, above all, more precisely. The goal is efficient management of complete construction sites. Digitalisation will give a further boost to process efficiencies and thus also to our sustainability successes. Wirtgen is currently rolling out its new John Deere Operations Centre, which will provide the hub for customers, not only for individual machine data that we have today, but starting to join up the individual machines into a production system on the job site. An example of this looks like in practice, and the future of both A2A and digitalisation is our 4D integrated road building. The production system for road rehabilitation consists of milling, paving and compaction. Starting with easy, efficient surveying of the existing road surface, the data can quickly and easily be uploaded into Operations Centre. This is in alignment with National Highways' imperative that smoother roads are linked to improved ride quality, longer pavement life and reduced road user fuel consumption. UK draft ride specifications based on measuring longitudinal profile parameters ELPV and the texture profile parameter mean profile depth MPD. Wirtgen is working with a surveying partner transitioning the scanner surveys for networks into a project level. Having taken the survey data quickly and efficiently within our design software within Operations Centre, the intended new road profile can be set and compared against the existing profile to evaluate the improvements to rideability that can be achieved. From this design, the data can be sent to the milling machine controls. Using GNS receivers mounted on top of the milling machine to provide accurate positioning of the milling drum, the proposed profile design that has been sent to the milling machine controls can run the operation in a highly automated way to the new target road profile. An example here recently undertaken in the USA, which has seen a dramatic improvement in IRR results. The design data can be transferred to the paver following another scan of the milled surface, or created from GNSS, field rover, or extracted from planned design models. The machine controls from the model using auto steer controls controls the paver and screed width again in a highly automated way. And using smart assistance and smart automation systems from HAM, such as Smart Guidance, Smart Compact and Smart Drive, the roller driver can ensure the optimal compaction of the mat is achieved. Managing the construction process as a production system with data transferring through the process through a unified data infrastructure should improve the outcome for the user through better rideability and improve efficiency and sustainability of road construction. To summarise, we as the Wirtgen Group are uniquely positioned to deliver both the economic and sustainable value for our customers and clients, and all of this through advanced technology and solutions that we develop in close cooperation with our customers and their clients and overall the partners of this industry. Thank you very much for your attention.